Have you ever really stopped to think about what you're seeing when you look at the world? I mean, really seeing. What if I told you that every single thing you perceive is actually a ghost from the past? Let's get into it. So, take a look at this beautiful sunset. It feels like a perfect single moment captured in time, right? Well, that feeling, it's a total illusion. This photo isn't one moment. It's actually a mosaic of countless different moments, all arriving from the past.
So if that picture isn't the present and what we see with our own eyes isn't the present either, then what in the world is this reality we're all experiencing? To get to the bottom of this, we're going to need a whole new way of looking at things.
The core idea we're exploring today says that our confusion comes from one fundamental mistake. We're constantly mixing up three different worlds without even realizing it. It's like confusing a map for the actual place it describes, mistaking the description for the thing itself.
Think about it like this. You've got an architect's blueprint. That's the perfect abstract plan. Then you have the actual physical building, made of steel and concrete. And finally, there's a photograph you take of that building. Those are three totally different things, right? But in physics, and even in our daily lives, we just kind of mush them all together. So the solution is to pull them apart. Let's introduce a framework that neatly divides reality into three distinct worlds: the mathematical, the physical, and the observational. This is going to be our new tool for seeing things clearly. Okay, so first up, we have the mathematical world. This is the blueprint. It's a world of pure, perfect logic. Like algebra, or geometry, or the rules of chess. In this world, something is true only if it's logically consistent. There's no time, no space, no actual stuff. It's just our perfect, abstract toolbox.
Then there's the physical world. This is the building itself. It's the actual universe out there, all the stars, planets, and atoms, governed by the real laws of nature, like gravity. The equations from our mathematical toolbox, they're just our best attempt to describe this world. They're the model, not the reality itself.
And finally, and this is the big one, there's the observational world. This is the photograph. It's the world of data, measurements, and images that our instruments, or even just our eyes, can actually capture. This is the only world we have direct access to, and it's always limited by stuff like the speed of light, delays, and the resolution of our camera.
So you can see how this all breaks down. For the mathematical world, you ask, is it logical? For the physical world, is it a real law of nature? And for the observational world, can we actually measure it? A lot of the confusion in physics, the argument goes, comes from asking the wrong question in the wrong world.
All right, so we've got this cool new framework. Let's take it for a spin. We're going to apply it to one of the most famous thought experiments in all of physics, Einstein's light clock, the one used to explain special relativity.
The setup's pretty simple. Imagine a pulse of light bouncing between two mirrors. That's one tick. Easy. Now, if that whole clock starts moving sideways, the light has to travel a longer diagonal path to get to the other mirror. And since the speed of light is always the same, that longer path has to take more time. So the conclusion? A moving clock ticks slower. Or does it?
But hang on a second. Using our new three worlds framework, we have to ask a super important question. Where is the person who's seeing all this happen? The diagram shows us 2 points of view at the exact same time, but no single person could ever actually observe that. So, who is this drawing for?
And this is where the whole thing kind of falls apart. The light clock diagram, it lives purely in the mathematical world. It's just a perfect geometric drawing. It pretends you can see the light's entire path all at once, which is physically impossible. It totally ignores the observational world, where the only thing that matters is when and where light actually arrives at an observer's eye or a detector.
So it all boils down to this really powerful point. A thought experiment that doesn't define an observer, well, that isn't really physics at all. It's just geometry. You're just drawing triangles and confusing the blueprint for the actual building.
So now that we have our framework, let's circle all the way back to that first photograph and finally figure out what we're really looking at when we see the world.
Okay, here it is again. But this time, we're not going to assume it's a single instant. Nope. We're going to look at it through the only lens that actually matters, the observational world of a camera just capturing photons that have been traveling through space and time.
So what you're seeing here isn't a snapshot of a single now. The key idea is that it's something called an equal arrival time surface. Basically, a whole collection of photons that all happen to arrive at the camera lens at the exact same instant.
But, and this is the wild part, they all started their journeys at totally different times. Think about it.
The light from the sun, that began its trip 8 minutes ago. The light from those clouds, maybe a few seconds ago. Light from the buildings on the horizon traveled for microseconds, while light from the closest skyscrapers only traveled for nanoseconds. They're all ghosts from different pasts, all arriving together to create this illusion of a single present.
And that, right there, is the big, profound takeaway. Our reality, the one we see and experience every single moment, isn't some clean slice of now. It's a continuous, overlapping mosaic of different pasts, all arriving at our senses in the same instant. We are always looking at a collage of history.
So, that leaves us with this one last kind of mind-blowing question. If everything we can ever observe is an image of the past, does a universal, objective, present moment even make sense? What reality are we actually living in?